Now, when we're dealing with 10.5 deals with integer exponents and scientific notation. In the beginning of this section, it look at the definition of a negative exponent. Okay. Now, when you're dealing with a negative exponent here, this negative exponent doesn't necessarily mean it's a negative. It means that although it isn't a negative number here, this also it also means the position of it. So here we have a to the minus n. What that means is that it really belongs in the denominator. And if I had something like this, what it means is that it really belongs up top. Okay. So along those lines, when we're multiplying exponents, if you recall, when we're multiplying exponents, we end up adding the exponents. And when we divide an exponent, we subtract. Okay. So that subtraction is coming from here. So another way of looking at this 2 to the fifth and 2 squared is 2 to the fifth. Now if we bring this one up top, bring it up here, we'll have 2 to the fifth times 2 to the minus 2. So now I brought it up top, which makes that 2 to the third power. So when you see a negative exponent, it simply means it belongs somewhere else. That's all it means. It belongs somewhere else. So when it comes to simplifying problems with exponents, for the most part, um, it's easier to go ahead and just rewrite the problem with a positive exponent and then simplify it. So if I had 4 to the minus 2, it's easier just to go ahead and rewrite it with a positive exponent and then simplify it. Or if I had 10 to the minus 3, that's the same thing as 1 over 10 to the third, which will be 1 over 1,000. So for this one here, what we have essentially is negative 3 raised to the negative 2 power. We can rewrite that with a positive exponent. That belongs down there, so I'll take it down. So it's like this now. So I'll bring it down here. Then I simplify it. 1 over negative 3 squared is going to be 1 over 9. Let's look at another one. Negative 3 raised to the negative 2. So what I really have here is negative 1 times 3 to the negative 2. So keep in mind this negative also has a position on it. So I can rewrite this as negative 1 times 1 over 3 squared. Because remember, it belongs here it belongs in the denominator when it's like that. Now I can multiply this out. I have a negative 1 times 1/9, which is going to be a negative 1/9 for my final answer. I guess. So we're multiplying here. So when you have more than one operation involved, you want to be sure to follow the order of operations. Let's take care of the exponent. I'll rewrite it. 4 times 1/2, which is 2 to the first power. So I end up with 4 over 2, which is 2. The next one we have here is 4 times 2 to the negative 1 power. You rewrite that one. Now we have 4 times 2 to the first power. 4 times 2 is 8. And that's our final answer. And there's alternate approaches you can take with this. So you can also do this here. Take care of the parentheses first. And I have 8 to the minus 1. So that belongs down here. I have 1 over 8 for my answer. Okay. Yeah. So always follow the order of operations. So do what's in the parentheses first, then take care of the exponent. Remember, variables represent any value. So the same things we can do with numbers, we could also do with variables. So if I have x to the minus 6, that's going to be the same thing as 1 over x to the 6th. So if I have 5y to the minus 1, that tells me that the y belongs on the bottom. So I'm going to have 5 times 1 over y, which is just going to be 5y. The next one we have quantity, 5y to the minus 1. We can't do anything in here, so we can just rewrite it as 1 over 5y. The next one we have a negative 5y to the minus 1. Okay, we can't multiply anything in here, so this all belongs in the bottom. Negative 5y to the first power. So we see we have 5y here. We have 1 over 5y here. We have a negative over here, and they rewrote it and brought the negative to the side and said 1 over 5y. Now, these are some rules you want to familiarize yourself with. Summary of exponent properties here. Okay, so now we're going to be simplifying using some of those properties. First one is we have is x to the minus 4 times x to the 6. Okay, there's different properties you can use to get the same answer. So when you're multiplying, you add the exponents. So here I'm adding a negative 4 plus 6. I'm adding different numbers with different signs. So I subtract the smaller from the larger. 6 minus 4 is 2. Take the sign of the larger, it's a positive 2. Okay. Next one is I have here y to the minus 6 times y to the 4. When I'm multiplying, I add the exponents, negative 6 plus 4. I'm adding two different signs. 6 minus 4 is 2, and take the sign of the larger, makes that a negative 2. And we write that with this positive exponent, 1 over y squared. Okay. Since the bases are the same here, we have z to the minus 5 times z to the minus 3. Since the bases are the same, we can just go ahead and add the exponents. So I have a minus 5 plus a minus 3 gives me z to the minus 8, which can be rewritten as 1 over z to the 8th. Okay. Now remember that multiplication is commutative, so you can move stuff around. Same thing here with these. We apply that property here. You see that. You have I have m to the 4th times n to the minus 3, and then I have m to the minus 5, n to the minus 2, so you can get our same bases together. So I'll have here m to the 4th times m to the minus 5, then I have times n to the minus 3 times n to the minus 2. So now when I'm multiplying here, they have the same base, so I can add the exponent. So I have m to the 4 plus negative 5 times, these are the same bases, n to the minus 3 plus a negative 2. So adding here, different signs, subtract the smaller from the larger. So I have m to the first power. Here they have the same. I'm adding, so 3 and 2 is 5. Negative m n to the 5th. Negative. And that's what I get there. And looking at this again, 4 and 5 makes that a negative 1, and that's a negative 1. So that really belongs all on the bottom. 1 m n to the 5th. Let's see here. Yeah. I've been working hard. Here we're multiplying. We have 2x to the minus 6. Then I have here times y to the 8th negative 5 x to the fifth y to the minus 3. So I'm multiplying. I can get my like terms next to each other. Like bases here. Yeah. Well, like bases next to each other. So these are both numbers, so I can put them next to each other. 2 times 5. Then I can get my x terms next to each other. Numeric terms. So I have here x to the minus 6 times x to the fifth. Then I get my y terms next to each other. Y to the eighth. Then I have y to the minus 3. So 2 times 5 is going to be 10. Then I'm going to have x to the minus 6 plus 5 here. Then I'm going to have here y to the 8th plus a negative 3. So a negative 6 and a 5. 6 minus 5 is 1. This will be a negative 1 here. And this becomes 8 minus 5. 8 minus 3 is 5. There. Okay. We can rewrite this with positive exponents. X will be on the bottom, y to the fifth up top, and a 10. And what else is there? Did I leave something out? Okay, there was a negative there. Negative, 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 and a negative. Okay. And that's that one there. Mm-hmm. This one here, we have k to the third raised to the minus 2. So rewrite that. Belongs on the bottom. We have k to the third squared. Yeah, also we have here, we have 3 times 2. So what we really have is k to the third times k to the third, which is going to be k to the sixth. You could also multiply this out and say 3 times 2 gives me 6. Okay.